So let us start directly with the discussion. So the format is you ask the question and then we start and see where it goes. Yeah, Lorenzo.
So I wanted to ask you, not only Marcin, also Gordana, what is your opinion about this kind of summary, if it is sufficient, if it is correct, and so on, of the various kinds of the various meanings of the word morphology and morphogenesis that emerged in this workshop. So I have seen, first of all, the meaning of morphology that is related, for instance, to the fact that we use substrates to enrich computations. It is the case of reservoir computing, first of all. Second, we have morphology, the general ideas on morphology, philosophical, cognitive, biological, of physics, from physics, as a source of heuristics to build computational programs. Third, we have an idea of morphology, for instance, organic agents, that indicates that they are in themselves the fruit of something computational. It is an implicit computational result. Four, we have, for instance, cellular automata that is a kind of computational system, if I correctly understood, that creates morphological objects. And five, we have also, to take the example of René Thom, a mathematical knowledge about morphology that doesn't have any computational aim, but only a mathematical that is at the same time, as René Thom says, a semiophysics of, so this is a kind of, so to say, traditional knowledge of morphology. So I wanted to ask you both, to Gordana and Marcin, if my summary of the various aspects is acceptable, is coherent with the presentation and so on. If I avoided to list other important things, because I'm always interested in a kind of all perspective about a topic. For instance, in my presentation, I only dealt with the problem of organic agents as possible substrates to be educated, domesticated for creating computation. That is completely different from the problem, for instance, of cellular automata. Thank you.
I think I would give the word to you, Marcin, who developed such a great background for morphological thinking. So please.
Yeah, I would say, yeah, you summarized it very well, but there is one problem, that it shows how rich is this direction. It is typically, it is not appreciated because people very often, when they hear morphology, they think it's in one particular way how this concept is used. So the thing which probably as a program for the future will be to more like systematize and to explain to people that we have to go beyond one particular meaning of the concept. Especially that morphology sometimes is used purely metaphorically, sometimes is used in like a very systematic way, but then narrow. So we need something which will meet both sides, that it will be wide and at the same time will clarify understanding or will organize the way about thinking about morphogenesis and its relationship to computation or to cognition. So I think you found like key points from our today's conference, but there is a long way to go to make it more more organized. But of course, partially I think it is because this is relatively new. Relatively new because of course Turing started this idea long time ago, but then there was a long time nothing happened. And there's only quite recent interest in his ideas. And then it turned out that there are many other sources and many other ways how morphology, morphogenesis can be used. On the other hand, we could see from yesterday, from, for instance, what Mike Levin presented, that this is one of most important things when we want to understand life, when we want to understand many other aspects. And for me, it was eye-opening that suddenly I could see that thinking only in terms of genetics is very, very narrow way of looking at life. And now I can see, well, this is a huge additional world. But even Mike admitted that his work with his research group has this limitation that is only about basically electric potentials and networks of electric patterns of electric networks, but they do not do this. Probably there are some kind of limitation in the resources. They don't do this magnetic side of this. So it shows that this is basically not a point where we could easily summarize everything. That this is huge domain of future research, philosophical reflection, and the place where young researchers can find a lot of interesting problems to work on.
May I add?
That's your piece.
I agree completely with both of you. It is a family of concepts, so it's not a single well-defined concept. And it is with a good reason when we are researching, we use the nets of concepts just to capture as much as we can. So that's a thing. And for example, in robotics, they are using a specific notion of morphological computing where they use the body of a robot to perform things that do not need central control. So instead of controlling by the brain how my hand is working, they use the morphological properties of material that they compose the hand of. So it closes and opens automatically instead of being each coordinate calculated and moved. So for them, morphological computing is directly using the body to perform behavior. But that's just one of many possible applications of the term. So I think indeed it's a complex network of notions, of concepts.
Thanks, Gordana. Thanks, Marcin. I agree. I totally agree. I think that it is also important to establish a kind of topology of the various concepts, also for the researchers themselves that can fecundate their research taking advantage of looking at other kinds of research. And also, this emerged mainly from the Marcin presentation. We have to stress the distinction between the exploitation of morphological aspects and the problem of morphogenesis. That was already addressed, as Marcin said, by Turing, that said this can be illustrated using mathematics, but we see that we can also illustrate using computational tools like cellular automata. Thank you to both. Thank you both.
Thank you, Lorenzo.
I can add something to the answers. When I started looking into my problem and I talked to Gordana half a year ago, she told me, oh, this really resembles morphological computing, you should look into that. And I started looking, and then the first hint is always this concept of morphological computing for robotics, in which, as you described, Gordana, is this idea of outsourcing part of the computation to the physical part of the robot that will effectively perform the action. And I found this concept a little poor for my specific problem, because in those cases, the morphology seems to be fixed. And it is the behavior that is dynamic according to the rules defined by this. When I try to apply this in my problem, there is a lot of freedom because it's a computational system in which I have several nodes and they execute programs. And I try to understand what is the underlying morphology here. Should we build it? And I think that this is where morphological computing and morphogenesis connect, in the sense that often you don't have this clear distinction of the material or the physical body, and you need to somehow create it. And that was my inspiration to look into morphogenesis and to see, like, okay, how does organism create new organs or new cells? How is this growth driven by the body? Okay.
Very interesting. I have a question for you, Guillermo. How do you see the development of your research in this specific direction? Do you think it is very, very far from any application, or how do you think?
Well, no, I don't think it's far for the easy problems, for the basic problems. I think that the generalization is relatively difficult, but what we already have, this self-healing protocol, it's almost embodied. It's like, it's the smallest part. So we need to think about what it represents, the exchange of messages that we have. We have a distributed protocol, and I want to see it as exchange of signals. I want to change my mindset and forget about messages and start thinking about signals. And then I think that these signals, they are easier to map on morphologies. And I think that's something we can do relatively easy. How to generalize, how to go beyond that, I have no idea. I think the idea of symmetry was super interesting concept. Is for me totally a new approach, and that's something I would like to explore, the connection between symmetry and synchronization. And actually I have a question to Marcin about that, because of the topology automata. How far are you into that? You know, because for me, what resonates is the idea that in my schedules, the schedules it's a dynamic topology. Whenever you assign a message to a slot, you are saying, okay, in this slot, this and this are connected as transmitter and receiver. So you establish a link. And in the next slot, this link disappears when you have a new topology because there are new connections. And I don't know if your idea of automata, of topology automata is compatible with this or is something different.
Yeah, like I can see there is so-called topological dynamics, all discipline. So probably somewhere there could be source of more specific concepts and theoretical statements about this. You know, like, I can see possibility, and for me it is like very natural that there will be application, because it is clear what you were saying is that this topological aspect is important. On the other hand, what you want to achieve is to have some kind of dynamical system. And here is traditional view of topology is not very dynamical. But there is something which like domain of study as which is called topological dynamics, and I could see over there something. In first step, I would say, you know, like I would advertise you to look, because as a first step, it doesn't mean that you'll find solution over there. But this René Tom's book about morphogenesis and structural stability is interesting. He has lots of great ideas, and in his approach, he's starting from dynamical systems, which are not only continuous, but typically trajectories are differentiable. But he is saying that the carrier of information are points of discontinuity, either points like attractors or points where there are bifurcations, because I think that in the case of your problems, it is very important that you may have points where one trajectory splits into two. Yeah, so there is all fear of bifurcations. So something like this could give you some view on things which are involved, where we have something which is disruptive. Because if something works, it works. The main issue is what happens if it doesn't work. Yeah, so discontinuity, it is something which is a natural point where you have to pay attention to this. And the big problem is, and this is why I think René Tom's work was not sufficiently recognized, that for usually for mathematicians, discontinuity, it is like pain in neck. You want to avoid discontinuity. You want to push it away. So what you do, you just start from making assumptions that there are no discontinuities. But then it turns out that this description does not fit the reality, where we have a lot of discontinuities. So I can see that, you know, like in René Tom's book, you can find some kind of inspiration, not solutions, because I think his work is quite actually his approach had lots of practical applications. I know that even things like work of heart, yeah, and problems with heart beating, there were some results which helped to medical practitioners to predict and to avoid problems of this type. So his work had already had a lot of practical applications, but in general, there is this escape from what he was doing, because he was so much preoccupied with discontinuities, where people, mathematicians, want to avoid them. But I think that René Tom would be a good start. And then topological dynamics, I think it is something which could be useful.
Great. May I suggest that you continue your detailed discussion? Any other comments or questions or suggestions for that we can share? Yeah, Dennis, please. Unmute yourself, please. You are muted.
Yes. Marcin, it would be great if we could work on, you know that I'm also obsessed with Darcy Thompson. And nobody tried to use with new principles, with computer modeling and so on. So I think it would be very nice if we could go back to the old time of Darcy Thompson. And please note the very strange fact that architect used his book very well, and there are a lot of transformation used, not in morphology, but in architecture. So it is very interesting. And secondly, Gordana and Marcin and all of you, I enjoyed very much this session. You know that we organized together with Marcin the conference on symmetry, structure, and information. And because you touch many times the concept of symmetry, you are warmly invited to our next Symmetry Congress in Porto, which would be in July, University of Porto, Faculty of Architecture. So we will keep you informed. So thank you very much for all of you.
Thank
and
you.
Congratulations to Gordana, Marcin, and all of you. So thank you.
Thank you so much.
Maybe I will make one follow-up of in this symmetry conference. There were some talks which were directly related to morphogenetics. There was one talk by, I don't remember his name, a young architect. Dennis, do you remember what he was from Colombia?
Akio Hizume, he's a genius.
No. Yeah, but I'm talking about this talk from South America. Young architect.
Patricia Munoz.
Maybe her. But anyway, there was talk where directly the idea was about use in architecture morphogenesis in sense of development of natural structures within architecture. Yeah, so there are these intersections. The big regret of mine is that we did not manage. It is practically, maybe at this moment it was impossible to stimulate more cross-fertilization, because basically some talks in symmetry conference were about morphogenesis. And I'm quite sure that for people in symmetry conference, it would be interesting to listen to some talks about morphogenesis. But when people are looking at titles, very often they are not able to decrypt what is behind it. And then another thing is scheduling, and this is something which we cannot resolve. If we have a conference where participants are all over the world, there's no place, no inhabited, no, there is one, unfortunately, we don't have representation of Africa. But otherwise, people are spread, so scheduling it is very difficult. So this definitely influences participation in this. But again, we have to look for the way how we can integrate all these directions, because in all summits you can see a huge variety of topics. I participate in many. Of course, I cannot participate in everything because there are time conflicts. But I can see, well, this talk is related to this to this, but it's not so easy in front of this to find it. I can see Gordana.
Yeah, I was just to mention there is a Stuttgart School of Architecture which is based on morphogenesis. So I will send you links. It's really exciting architecture. So maybe as a suggestion for a keynote or something. But I was thinking, Krasimir and Guillermo, I don't know who was the first one, they were waiting for a long time. Let's say Krasimir.
Oh, thank you very much. Sorry for my camera is not working now. I'm very happy to participate in these events. Thank you very much for organizing this. For me, this is very, very important to listen, not to speak, but now listen
I
to
wish
you.
we would like to hear you. We would like to listen to your presentation, but next time.
Yes, I want to show one example how we need to study the nature and to implement it in our real. I think our conference is a very good example what we may use to realize. And I will show one diagram of already existing work for processing big data. Now I'm waiting to start sharing. Okay, I think it starts.
Yes.
Now
We see your screen.
okay, this is diagram. This is one how to say new approach basic for processing big data. One alternative of well-known MapReduce paradigm of Google, and now you see how many difficult connections there is in MapReduce paradigm. If we teach, if we study how we provide conference, we may see that we have very simple approach to collect data, to collect knowledge, and after that, only what is needed to be presented, like this seminar. And I am very happy that I see in reality working variant of collect report paradigm. This really is very good working, and of course, so little energy, little resources are needed. So this is what I want to remark. Thank you.
Thank you very much, Krasimir. And Guillermo has also a comment or question.
Yeah, comment and small question is to Anna, because I mean, I found your talk fascinating, the topic super interesting. But of course, it's very new to, at least I guess, for most of us. So it's very difficult to come up with intelligent questions. But I was wondering, at least your point of view about the like next level, even more futuristic interaction between robots, because I mean, once they are able of complex thinking and complex reasoning, artificial intelligence will also require communication or dialogue and exchanging. And it's also I think your view that this needs to happen in those physical environments. So we'll like robots sit down at the table and play with those things in order to exchange ideas or to learn new things. Is that part of the future?
Well, you said you couldn't make very intelligent questions. I'm glad you didn't put more even, because I couldn't answer them for sure.
It's always easier. You know, it's easier.
This work is very exploratory, but I think I am interested in this. I'm particularly interested in this notion of augmented intelligences. And I think I'm not a computer scientist, as I said, but I've heard computer scientists deal with the fact that the field has been announcing for decades, right? The big breakthroughs that really don't happen because the complexity breaks, right? Because precisely we're trying to mimic systems that are too complex yet to be captured. And I'm more interested in this idea of using these tools really to augment and to support our complexity. And I think the idea that I wanted to explore was also because AIs have been failing to some extent. There's a point where they haven't been able to progress. And a lot of that has probably to do with the complexity of our embodiment too. You know, what a big breakthrough will be to have an AI do what a 1-year-old is capable of doing very intuitively, right? Because they can act in the world and they can integrate huge varieties of information and make decisions, and we still can't do that. So I guess what I wanted to explore was this idea. On the one hand, we have limited capacities to process information, to integrate, to keep it present, for example, right? Not to forget things, or we look at 2 things or 3 things and then we can't add a 4th because cognitively we have problems with this. So we can use these tools to somehow help us make these movements and to keep the information available for us as we need it, so that we can then make more complex constructions. But I guess what I wanted to play in the talk was also with the opposite, which is that we could be more of the embodied dimension of the AI to some extent, that there could be this sort of synergy, that our own embodiments, that information that we're capable of creating could somehow be, that somehow an AI could be operating on us, if you want to. I played with that idea, for example, of a tool that it's on me, right? That accompanies my movements, that uses the information that I'm capable of producing as I'm manipulating information, even symbolically. But I don't. So just to say that I'm more interested in this idea of augmentation and amplification than of fully independent intelligences that are going to match us, right? And so it's really, but we are complex, but yet our modes of thinking have been very reduced and very restricted. And this idea of complex thinking is somehow to recover these organizational principles of biological complexity, for example, in the way that we manage information, right? And maybe some tools can help with this and can help us perform movements that we can't do, relational movements, for example, or do recursive loops, but above all to integrate the information in a way that alone we can't do. But then we can do the rest. We can sense and we can add other dimensions to the information, I guess.
Would you agree? Would you agree if I say that we are looking for synergy between human and some form of technology?
Yeah, exactly. I think I see that is something that I would be much more interested in exploring. For example, I work with clinicians. I didn't tell you this, but I work with practitioners that work with very complex cases. So I told you I'm a psychologist, and we deal, for example, with cases of child protection, where we have to make very difficult decisions and about the potential for change of a given system. And we have to design interventions in cases where families, for example, are affected by such a variety of challenges that one intervention can just really mess up, many other dimensions of their life. And practitioners often fail because they can't grasp the complexity and the relationality of that kind of system. But they still have, and a lot of practitioners do have, this intuition that comes with practice that can't be replaced, by any sort of algorithmic type of other thinking. But they also make mistakes because of that at the same time, right? Because then they can't organize the information in sufficiently complex ways. So if we have tools that kind of like build upon some of our more intuitive modes of knowing, but make them more complex if you want to, by the way that we're then able to put this information to circulate, as I said, between those landscapes of beings and the landscapes of abstracting, then maybe we can compensate and take advantage of this this interaction between the system 1 and system 2. So I would say that it's in the synergy, definitely, that's in the complementarity of modes that I think something interesting could come, and maybe more practical and more promising than expecting for the full realization of fully autonomous AIs, or at least that match a 1-year-old.